Hi, so this is question 18 on June paper 2019, question paper 2. It's a circle theorem question. You are actually after an angle though this time, but you do need to show all your workings, which means you need to know some particular proofs. Okay, so if you want to pause it and have a go, and I'm going to now go have a look at this for you. So lots of things to know. There's lots of things going on, and they've kind of helped you out in a lot of ways, to give you these kind of lines, which means that that is an isosceles triangle, and therefore the angle here, BAD and BDA, are the same. So I'm going to do all my workings first, and then I'm going to structure it out to say what do you need to actually write. So here, these are going to be the same, and we know they all add up to 180. So 180 minus 40 equals 140, and if you divide that by 2 to get 70, that would be these angles here. Okay, and that's because that's an isosceles triangle. That's one thing. We'll write that out in a minute. Okay, another thing, you've got another isosceles triangle here. So you know that this value, CDB, and let's use a different colour, CDB here and up here are going to be the same. We'll call them Y. So we know that already, and we know that this is going to be the difference between those. Now, this is where circle theorems come in. If you'd just written that, this is a bit of a clue really. If you don't know your circle theorems, because they are not always that easy, but if you don't know them, and you just get to this point and write on there 70, that will be worth a mark, okay, in this particular question. So you must use whatever you can just to spot that that's an isosceles triangle, and that they need to add up to 180. Okay, don't just leave these questions because they look scary. Just have a go, because just to get that one mark is really important at such a critical point. 18, question 18 is near the third from last, I think, on this paper. Just get those marks in. Okay, but if you do know circle theorems, you should know that a cyclic quadrilateral, so a quadrilateral that fits inside a circle, which is what we've got here. If you forget that they're triangles, they are triangles, but they're also a quadrilateral if you put them both together. So therefore, the two, each opposite, would equal 180. Okay, so that is one of the circle theorems. So if that's the case, then 180 minus 70 was 110, and so therefore this one must be 110. And then when we've got that, we can then do exactly the same as the other one. We know one here, and we don't know the other two, and then we divide that by 2 to get these two isosceles angles here. See, they're going to be the same. So 180 minus 110, and therefore this one is going to equal 35. So these little y's here are going to be 35 each. Okay, just look at the, yeah, that would definitely be, just, even if you didn't write anything, just getting this 110 will give you a mark here. Okay, so what is the angle we actually need? ADE is the angle we need. We actually need this one here. So this is just angles on a straight line now, because you've been told CDE is straight. CDE is straight line. So you've got two of the angles, so the third one will be just 180 minus 70 minus 35. I'm not saying this is the best way to structure it, it's because I'm trying to show you the picture and write down. You'd probably try and do this lower down, but they can read it as long as it's structured. They can normally read it. So 180 minus 70 minus 35 should give you so it should give you 75. Yeah, because that's 70 and 35 are 105 minus that from 180. So this one here is 75. Now they're never to scale, But if I came up with a number that was tiny, I would think that might be wrong, and you might want to check that out. Same as if 35 came bigger than this one, for example. They're not to scale because they don't want you to measure them, but they might have some relative scale. I mean, this one in the middle isn't particularly very good because I'd say that's bigger than 40, but they will have, you know, like this one is over 90, so if you did that 70, if whatever you got this bit wrong, so that was 70, that might flag up that actually that doesn't look right. But so just be careful. Don't always rely on that, because like I said, it's never to scale. All right, so now we know the value. Again, that just doing that would probably give me 3 marks. It would give me 3 marks, but the extra 2 marks are explaining why. Okay, so you must give a reason for each stage of your working. So for example, what I would do here, so BAD equals BDA, because it's an isosceles triangle. And then you'd go BD equals 70, and then you might want to put in there, you've already got the workings up here, and then divide 2. So that's telling you about this x over here. Okay, then work to the other one, so then find out this BCD. So BCD equals 110, and that's because of opposite, excuse my writing, angles in a cyclic quadrilateral add to 180. And you've already written all the working up here. You don't really need to write it out again. So opposite angles in a cyclic quadrilateral add up to 180, and therefore they can see that you know what that's about. And then CDB, so CDB equals 35. Again, I would write isosceles triangle. Because of isosceles triangle, you could do the calculation, but you don't need to. That's all up here. You've kind of done that already. And set, so CD, sorry, not CDE, ADE is which one we want. And so that's kind of the one you want. Therefore, ADE equals 75 degrees because of angles on a straight line. As long as you've got this story, as long as you know you're using this terminology with the angles, and you've got all the workings involved, normally you get, if it's a 5 marker, it'll be 3 marks to find the angle, if it's an angle solving. So make sure they're really structured and you can see on the picture or somewhere the angles. So I've got them in both on this. And you've got at least a few of these steps why. The one on this one, when I looked at the mark scheme, opposite angles in a cyclic quadrilateral, that got you 1 mark. And the other mark comes from either saying about the isosceles or saying about angles on a straight line. So it's either one of them. So just go to town, but don't be wrong. Just try not to go too crazy. Just work in a structured manner. And obviously, if you wanted to do this 180 minus 70 minus 35, you could do that, but it's not necessary. You've got that up there already, and it's really just showing that you've got the right calculations and you're telling them why. And be obvious. Even angles on a straight line, you might think, oh, that's obvious, but just write it anyway, because you never know, that could be the extra mark. Okay, so that's a little bit tatty, but that is a proof of why that angle is 75 degrees. So I hope that helped. I do try to give tips along the way because I know that these questions can be tricky and they're never going to be the same, but they might have similarities. So just break it down and try and do everything that you can do in that exam situation. Okay, thanks for listening.